Hello everyone, I welcome you all to this session. In this session, we are going to start with our experiment number 3, named as file manipulation using system calls. So, you must be able to understand, or you are already aware about the term manipulation. File manipulation means there are different operations we can perform on the files. Let's say you want to create a file, or you want to delete a file, or you want to write some content inside a file, or you want to update the written content inside a file, and you want to check different types of information about a file. Whole lot of different operations we can perform on a file, right? So in this experiment we are going to operate on files and try to deal with different issues, right? System call we have already discussed in the theory class. System call provided by the kernel. These are, you can say, functions or routines available through which a user program can interact with the kernel, right? So through system call, a user program can take the permission. So generally there are different categories of system calls. Throughout this lab, you will be going to use a few of the system calls, those I have mentioned here. So the very first thing, the experiment 3 is about the file management related system calls. Then after we will discuss about the process control or process management related system calls. There are device management related system calls also. Then information management maintenance related system calls also. And then communication like interprocess communication or network related socket programming or something. If you want to do, there are separate category of system calls, right? So for this session we are focusing on the system calls related to file manipulation. There are different system calls like open, read, write, close. So what is the role of open system call? If you are not aware about, then you can use the man command. So you type man space 2 space open and you hit enter. It will display you the manual of the open system call. So in the manual you can find out how many header files you need to include in order to use open system call, how many arguments you need to pass in open, what will be the return value of open system call. All these things you will get in the manual. So we use the open system call to open a file which is already created, or we can also use open system call to create a file. If a file doesn't exist in the system, you can use the system call open to create a file. Okay, so there is a flag o_create flag you need to set for that. We will see later. Then the next system call is read. So as the name suggests, the read system call we use to read the data or some of the data from a file, right? So before reading a file must be opened in either read mode or write mode. Okay. Then the write system call, as the term suggests, write system call we will use to write some of the data on a file. And then close, the close system call we use to close a file. So if a file is open, its file descriptor will be opened and the close will close the file, right? Then lseek actually, generally when we start reading or we open a file, the file pointer will be in the beginning, or you can say the very first character. So if you want to write or read at a very specific location, or you want to read data from a specific location, let's say you don't want to read first 10 characters, you start reading from 11th character, then you can use lseek and you can specify the position from which location you want to read. Stat is also a useful system call which can help you to display a number of information about a file. So let's say you want to check the ownership of a file, or you want to display the inode number of a file, or you want to check how many blocks are allocated to a file, or n number of different things you can print about a file using either stat or fstat system call. Both are almost similar, right? So you can check the manual of all these. Then there is a truncate or f truncate system call. Truncate system call we generally use to resize a file. So if a file is allocated with a number of blocks, if you want to reallocate those things, then you can use truncate or f truncate, right? Then mkdir, it is a system call also. We have studied mkdir as a command also. There is a system call mkdir you can use to create a directory, right? Then readdir, if you want to read the directory content which is available inside, you can use readdir. rmdir will be used to delete a directory, and unlink is one of the system call which we can use to delete either a directory or file. So it will unlink means for deletion purpose, and rename for rename purpose. So rename will take two arguments generally, the previous name and the next name. So it is very easy to use. Now let's quickly look all these system calls through manual. So I'm just highlighting. In your syllabus you need to study primarily these: open, read, write, close, lseek, and we will also discuss mkdir, readdir. You can use rmdir or unlink kind of system call, right? So only these start system call you need to practice for your CSE 3 to 5 lab, right? The rest of the things are also easy. You can practice if you want. So let's jump on to the actual practice on the command prompt. Okay, so let's quickly check the manual of open system call. So man space 2, you type open, and when you open the manual you can find out the description: open and possibly create a file. So open system call can be used for two purposes. It can open as well as it can create a system call, right? A file can be created also. In order to use this system call, you need to include these header files. So sys/types.h, sys/stat.h, and fcntl. So these are the required files. And if we want to use open system call, we need to pass here a const char type pointer. That means const is one of the keyword you must be familiar in C. Once you define anything as const, that variable can be initialized only once. So during the program execution, only once a value can be assigned. If you want to modify that value, it will generate error, right? Then there are certain flags, or you can pass some mode also. So what are the flags and modes? Like flags and modes you can read out. It is given in the manual. So you just need to scroll down and the manual will give you all possible link. Okay. So if you scroll it down, you find out some of the flags like o_rd only, o_wr only, o_rdw. So rd only means read only mode. You want to open a file in read only mode. O_wr only means write only mode. And o_rdwr means read write both. Okay. So in both the modes you want to open the file. Then there are some other flags. So if you want to create a file, you can set o_create. So you will see later on. So you can read the manual and you find out a number of different things like o_create. So if you want to create a file which is not created inside the system, then you can use this particular flag, right? And finally you can give a number of permissions. So if you want to provide some of the permissions, there are two ways to provide the permission when you are creating a file. You can use like s_i_rwxu. So the meaning is you are giving read, write and execute permission to user. The same thing you can also pass like 00700. Okay. So if you have used chmod command when we were practicing permission updation, then you must be familiar with this 00700 kind of thing. This is I_RUSR. That means you are giving read permission to user, so it is 4 only. WUSR means write permission for user. XUSR means executable permission for user. RWXG means read write execute permission for group user, and so on. So easily you can understand all these things once you go through the manual, right? So this is the manual of open. If you want to check the return value of open returns a file descriptor, that is an integer, right? So you can check in the manual. There is a return type will also be defined. Okay, so you check the return type by scrolling it down. Okay, so you just check it. Yeah, so return value of open, it is saying file descriptor, right? New file descriptor, and it returns -1. Otherwise, if there is any error, find out, right? So that is manual of open. If you check the manual of, let's say, read, then if you want to use the read system call for reading a file descriptor, right? Read from a file descriptor, and you will get the file descriptor from open. So open return a file descriptor, whatever the return value of open system call will generate, that we can pass in the read system call. So you check it. In order to use read, we need to use unistd.h header file, and read actually require one file descriptor here. So this file descriptor, or we can return from open system call. So we pass that, whatever the return value of open will be there, we can pass here. Then we need to give a memory location. So it may be a character buffer. So whatever we will read from this file descriptor, that will be stored inside this buffer. Okay. And here we need to specify the count, how many characters we want to read or how many bytes we want to read, right? So if you mention 10 from this file, for which the file descriptor we will pass here, 10 character will be, the function will read and store inside this buffer. Okay, so once we code it, you will easily understand. And later on, if you want to print the read value, whatever the character has been read, you can print this particular buffer. Okay, now let's check the write. So if you want to check write system call, in write system call, we use the file descriptor to write. So we pass a file descriptor on which we want to write the data, and we pass a buffer or character array, you can say, or a string, which we want to actually write on this particular file descriptor. And we can specify the count, how many number of bytes we want to actually write. So this is very easy to understand. The same header file we are including here, unistd.h. So it is not very difficult to understand, right? Return value will be negative if it fails. Otherwise, it will return the equal number of character which we are writing. Similarly, the return value of read is also the size, or you can say number of bytes, which will this function will be reading. Okay. So if 5 character, if read will read, it will return 5. If 10 character, it will return 10. Similarly, write, if write is writing 10 character, it will return 10. Very simple, right? Now, if you use close system call, in close system call, you can pass a file descriptor which you want to close. So if you want to close a file, you just pass the file descriptor value here and use this close system call, it will close the file. So I hope it is clear to you. Let's see the example. So let's say if I list out some of the thing, so let's say I open the read.c file. So first there is a simple code written by me, you can check it. So let's say there is, I want to use read system call. For reading, I need to use open system call because file descriptor will be given by the open system call. So I'm assuming here that sample.txt file is created already. Okay. So a sample.txt file is created. I want to open that file in read only mode. O_rd only means read only. This buffer you can take as per your requirement. If you want to read 10 character, 20 character or so, you can decide the size. It is a character buffer, right? These header files you can get to know that by looking at the manual, which header file need to be included. Okay. Now this sample.txt from your present working directory, if the file is existing, it will read, open and read only mode. And if the file is not available or maybe the required permission is not set, then it will return you error. FD will get -1 value, as I have already shown you. The return value of open will be -1 if there is an error. So if the error is there, you can print that error. So this p error function actually pick up the error, system generated error, and it will display on the screen. So if you're not comfortable with p error, you can check the manual of p error. Just previously, whatever the library function or system call you are using, you just give the name of that. Related to that function, library function or system call, if any error is there, this p error will display on the screen, right? So this is very simple, easy function. And then you are returning 1. In case there is no error, then this part will be executed. So in this, what exactly we are doing? We are reading from this file descriptor, and we are reading actually 10 characters or 10 byte, and 10 character we are storing in buffer, and buffer is of size 10, and we are saying we are reading this thing until and unless it is not equal to 10. Okay, so once it will become 10, then it will stop reading, right? And in case any error comes, then this p error message related to read system call will be printed on your screen. Okay, and then actually we want to print whatever we read, we want to print as a string. So because it was a character array, so end of the string character I'm writing at last. So here I'm reading, let's say 9 character. Once it will become 10, this loop will terminate. So ultimately 9 character will be stored, and 10th character, the end of the string character, will be stored here. If you are getting it, it's fine. Otherwise it is very easy to understand. I'll elaborate you in the further coming sessions, right? So then this string will be printed, and whatever the buffer you have taken, that value will be printed on the screen. Okay, so let me execute this. So there is a sample.txt file. If I get sample.txt, it is having hello world, right? Now I am executing my read.c file. It is executed successfully, and when I run by typing a.out, it will give me. So this is the read output, and it is reading 1 2 3 4 5 6 7 8 9 and 10 character it is printing, right? So because we were trying to read 10 characters, and it is printing the 10 characters. Okay, if you want to read from keyboard, then the file descriptor of keyboard is 0. So please do remember, file descriptor fd of keyboard is 0, and fd file descriptor for screen or monitor is 1. So please do remember, if you want to write something by using write system call on screen, you can use file descriptor 1. So let's look at the example of writing. So look at this sample program I have written for writing. So let's say I'm opening that sample.txt file. I want to write some of the data. The data you can specify anything. I have specified hello, world. Okay. And so this data I want to write in this sample file. And this sample file I'm opening in RDWR. That means read write mode, both mode. So I can read it and I can write it also. Read write mode, right? Now, if this file is not created, then I'm also setting o_create. So this is or sign or pipe. If it is working, fine. If it is not working, then create. O_create means create a file. And the permission when I'm creating, then the permission will be 0666. 6 means read write for user, 6 means read write for user, and the third 6 means read write for others. So this is the group user, First is user, second is group, third one is other users, right? And then we compare if the return value is less than 0, that means negative, there is an error. And we use the p error message to print the error on the screen. System generated error will be printed. If there is no error, right, that we assume, obviously there will not be error if the file is existing and it is having required permission. Then we use write. We are writing on that file descriptor, and this file descriptor has been written by open function, right? So here fd is the return value of open. That return value we are using here in write. Okay. And this buffer which we want to write on this file descriptor, and that buffer is having hello world, right? And number of character. So from this buffer, how many character I want to write inside the file. So let's say I want to write 15 characters. Until it will not become 15, then we keep on writing. And in case any error comes, then we will display the error, system generated error on the screen, and then return. I hope this is easy to understand. So if you look at, now I'm deleting the sample.txt so that it can recreate it. So I can use rm command, sample.txt. I'm deleting it. So it has been deleted. Now there is no sample.txt, you can check. Okay, there is sample.c file, but txt has been deleted. Now I want to compile, so I will use gcc, then write.c. It is successfully compiled. Then I can use /a.out. Now if you check whether sample.txt is existing, it has been created. And if you check the content of sample.txt, then you check hello world is written there. So that means this program, and if you want to look at the program, you can use write.c. So the program is this, right? So this program has returned, if the sample.txt is not there, it has been created, and this content has been written on this. If you change this constraint, it will write something else. Okay. So this is the sample of reading and writing. This is the sample of reading and writing. Now, if you are facing the difficulty, I can make it simple for you, right? So let's check it. Let me come out of this. Now, if you want to create a very new program, the fresh program, you are not aware about the write system call or read system call, then what you can do is, let's say you want to use write system call, you check the manual of write. It will tell you which header file you supposed to include, uni.std, uni.std.h, right? And you need to pass 1, 2, 3 arguments, and the type also you can check it. And the return value is s size. That means it is also the number of size which you are going to write. That will be the return value. So you just write the program. So I will say, let's say for writing, I am writing write1.c from scratch so that you will get it. Then you include, so you include unistd.h. You can also include, if you want to print something, then you can include stdio.h. If you don't want to print, then that's fine. You may include fcntl.h if it is required. Okay. Okay, then let's say int main. And you can return something. Return statement is important, right? As I have demonstrated in the previous session. Now let's say I want to write hello world on a screen. Okay. So I can use write system call directly. In write system call, I need to pass first argument as file descriptor. I told you the file descriptor of a screen is 1. Now here either you pass a character array or you can write the string. So let's say I write hello world. And how many characters are there? I want to count this. So this is like 5, 6, 7, 8, 9, 10, 11, 12, 13, let's say. So I write here 13 character. Okay. So this is my code only. I am writing hello world on this file descriptor 1, and this file descriptor 1 is associated to screen. Okay. So let's check what happens. If I run gcc write 1.c, and if I run it, it is working fine, right? Executing. Now try to execute. If I execute it, it is printing hello world. I hope you are getting. So write system call is very easy to use. Similarly, you can use read system call. So if you want to read something from screen, then you can use file descriptor 0. Okay. So let me open the same file, and if you want to, let's say, read something, so you can use read, but for reading you need some buffer, so you can take character, let's say buffer of, I would say, let's say 10 size. For the sample you can take it. Now in read, you are reading, let's say, from 0, and you are storing in this buffer, and 10 character you are reading. Now once you read it, I'm not applying that error message, I'm just making it simple. Okay. Once it is you are reading, you want to write this on the screen. Okay. So let's say instead of writing this hello world, I write here buff, and because 10 character I'm reading, so I'm writing 10. So what this program will do, it is reading some of the character, or you can say 10 characters from 0 file descriptor. 0 file descriptor is associated to keyboard, and once this reading will finish, then in this line, the next line, this write system call is writing on file descriptor 1, that means screen, and it is writing from this buffer 10 characters. I hope it is very easy to understand. Now you can run it. So if you run this, it is working fine. Now execute. So /a.out. Now it is holding. Holding means it is taking some of the input. So let's say I give apple, and it is printing apple. Are you getting it? So let's say if I run it again, I give, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. 10 character I am giving, it will return me 10, because it is taking 10. But if I give more than 10, let's say, if I give 1, 2, 3, 4, 5, 6, 7, 8, 9 more, then let's see what happens. It is giving you error because you are giving more characters. As per the expectation, only buffer size is 10, right? So let me show you the code, and then we will close this session. Okay, so this is the code. I hope now you are comfortable with read, write, open, and close system call. Okay, so you can post your doubt in the comment section. I'll take up your doubt and prepare the further sessions accordingly. Thank you everyone for connecting. See you in the next session.